All right, welcome back from spring break. We're going to start our second half of chapter 9 today. And so the second half of chapter 9 is going to be dealing with trigonometric ratios. And we're going to talk about what those are here in a second, how to set them up, and how to use them to solve for missing pieces of a triangle. So eventually, after the next couple of sections here, we should be able to find any piece of a right triangle given either the angles or the side lengths using what we call these trig ratios. And so the first thing we're going to talk about is what they are. So a trig ratio is a ratio of lengths. So it's a ratio of the lengths of the sides in a right triangle. So we're just going to take one side divided by another. So when we talk about ratios, that's just like a fancy word for fraction. So we take one side divided by the other. And so in a triangle, a right triangle, when we talk about our trig ratios, we're talking about sine right here, and we're going to abbreviate that with the SIN. We've got cosine right here, which we abbreviate with COS, and we have tangent, which we abbreviate with TAN. And so these three shortcuts, these abbreviations, are all found on your calculator. And so that's what we're going to be using for the most part with these types of problems, is we're going to be plugging things into the calculator using our sine, cosine, and tangent buttons. And we'll kind of get to that as we go through the different types of problems. Now in a right triangle, typically what's going to happen is you're going to have two acute angles, so A and B, and you're going to have a right angle, which in this case we labeled C. When we look at the triangles, typically they're going to be labeled, and so capital letters, it's important to note here, capital letters always correspond to angles, so any angle is going to have a capital letter associated with it. A lowercase letter is going to go to the sides. So any of the sides are going to be labeled with lowercase letters. Now, as we look at this, and we talk about sine, cosine, and tangent, it's going to be important to understand that we can do the sine and cosine for A. We can do the sine and cosine for B, the two acute angles. We can't do it for C, and you'll see why here in a second. So this is just kind of introducing what are the different terms, sine, cosine, tangent. And then as we look at the triangle, we're going to get these kind of labels, and as we work through some of the examples, it's going to kind of hopefully make a little bit more sense as we get to the different parts and the angles and sides and how they relate. So for trig ratios, we're going to try to remember this mnemonic device here that's just like an abbreviation called SOHCAHTOA. So this SOHCAHTOA is what we're going to use to determine how to set up our different trig ratios. And so for the SO, which I'm going to highlight here in orange, so for the SO, the S stands for sine, the O stands for the opposite leg, and the H stands for the hypotenuse. So the SO part of it, it's like the sine, so the first letter tells you which trig ratio, so S is sine, and then it goes first letter or second letter over third, so opposite leg over hypotenuse. So opposite over hypotenuse. So if I look over here at this example here with the triangle, if I'm looking at the sine of angle A, so angle A is right here. If I want the opposite leg, opposite means directly across from, so directly across from angle A is lowercase a, so that's the top of my fraction. And then it says the hypotenuse. Well, the hypotenuse is always directly across from the right angle, and so C would be my hypotenuse. So whatever those numbers would be in a problem, I would put A over C. And that would be my sine ratio. Now, as we look at this and kind of investigate further, when we go to cosine, so I'm going to grab a different color here. So cosine, I'm going to highlight here in pink, has an A and an H. So the C stands for cosine. The A stands for the adjacent leg. And the H again stands for hypotenuse. So this is what we're looking at with that second part of the SOHCAHTOA. So the C is cosine, A is adjacent, H is hypotenuse. Now again, we're starting at angle, or so when we come over here and look at this example then, so as we kind of see what this looks like, we're starting at angle A. So we're here at angle A. Cosine says adjacent and hypotenuse. So we want the leg next to my angle. So the leg next to my angle would be B. So that goes on top of my fraction. And then my hypotenuse is still directly across from the right angle, so it's still C, so I put B over C. For tangent, So if we highlight tangent here in blue, so for tangent we have O and A, which we've already seen before. So when I look at tangent here, O is the opposite leg and A is the adjacent leg. And again, it's second letter over third, so it just kind of goes right in order. Which trig ratio am I using, S, C, or T? And then the next letter is on top, the next letter is on bottom. And so if we look at our picture here, and we come over to this example here for tangent of A. So we're starting at angle A still, and as I look at the setup, it's opposite over adjacent. So I've got my fraction. The opposite leg is directly across, so that's my A. And then I want the adjacent leg, which would be B. So knowing the difference between hypotenuse and leg is going to be extremely important, because for an angle, it's always going to be next to the hypotenuse, but we only want to use that when we're talking sine and cosine. So be really careful with that as you get these setups. So let's go to an actual picture with numbers and see if this can't make a little bit more sense for you. So as we're looking at this example here, it says express each trig ratio as a fraction. Ignore this decimal to the nearest 10 thousandths. We're not going to worry about decimals right now. We'll get to those when we start solving the problems. So for right now, I just want you to be able to set up a ratio just like normal. So for sine of angle A, so again, we kind of highlight the angle that we're working with. So we're going to have a fraction, one number over another. So I'm going to highlight angle A here. So this is where we're starting. Now what I would suggest doing is, if I'm looking at angle A, I would come into this picture and label all three pieces of my triangle. Now the one that I would definitely label every time is the hypotenuse. Like that's just a given. Anytime we're dealing with a right triangle, we need to know where that hypotenuse is, because that's going to be an important part of everything we do. So there's my hypotenuse. Now if I'm at angle A here, the opposite leg would be all the way across, and so that would be the 12. That means the adjacent leg, the only piece left, would be the 5 here next to angle A. So this would be one of the first things I do, label all three sides so I know which pieces are which. So now when I go to actually set up my fraction, sine of angle A, sine, if we think back to the O and the H here, means opposite over hypotenuse. Well, I said the opposite was 12, and I said the hypotenuse was 13. So I just put 12 over 13. If I go to cosine of A, so cosine, we look up at our SOHCAHTOA, was adjacent over hypotenuse. And so now I have the adjacent labeled as 5. So as I look at my fraction here, I got 5 on top over hypotenuse, which is 13. And so there's my ratio. And then for tangent, tangent said opposite and adjacent. And so the opposite I labeled was 12. The adjacent I labeled was 5. And there's my ratio. Now, if we look at the other angle, so in this same problem now, they also want to know, well, what happens with angle B? So I have angle B here. And so if I highlight that in blue, now I have to readjust. So for angle A, my opposite was 12, my adjacent was 5, my hypotenuse was 13. So right now, I'm going to go ahead and get rid of that adjacent and that opposite. The hypotenuse doesn't change. No matter which angle I'm looking at, the hypotenuse is always the same. But now from angle B, the opposite leg would be directly across, that's the 5, and the adjacent leg, the one next to it, is 12. And so now, when I go to set up my sine, cosine, and tangent ratios, I need to take that into account. So now if I look at sine, so I'm going to highlight up here in blue, that's opposite and hypotenuse. Well, so I said opposite was 5, so that goes on top. Hypotenuse was 13, that goes on bottom. And then as I work my way through, cosine was adjacent over hypotenuse. I labeled the adjacent as 12. The hypotenuse is still 13, so there's my ratio. And then as we work our way to tangent, that's opposite and adjacent. So the opposite I labeled as 5. The adjacent I labeled as 12, so I just put them into a fraction. There's my ratio. So when it says to express the ratio as a fraction, that's all they're asking you to do. Find the opposite, the adjacent, or the hypotenuse, and put them together in a fraction. Okay? Now, calculating trig ratios, so actually like figuring out what the numbers associated with the different angles are, is just a matter of plugging into your calculator. And so right here it says make sure your calculator is in degrees mode. This is something we can help you with in class. Most calculators, the default is degrees. So you shouldn't have to worry too much about this. But if you do, we'll address that in class as we go through this. Now, as far as calculating trig ratios, so as far as plugging it in the calculator, you just type it in basically how you see it. So for most of you, based on the calculators you've been using in class, you're just going to find the sign button on your calculator. So you hit sign, and then it wants to know what the angle measure is. So you type in 42, and then when you go ahead and hit enter, you should get a decimal. And in this case, you get a decimal of 0.6691. So the sine of 42 degrees would be 0.6691. And so right now we're just getting some calculator practice. Now for some of you, your calculators are a little bit different. And so if you try to hit sine 42, enter, and you don't get anything, or it says error, then your calculator works a little bit differently, and you're gonna have to type in the 42 first, then hit the sine button, and it should give you the decimal. So if you have that type of calculator where you try to type in sine, then 42 and enter, and you don't get anything, then you want to hit the number first. So hit the angle measure 42, then hit the sine key, and it should automatically bring up the ratio. And so for then the rest of these, as we plug them in, so cosine, now we find the cosine key, type in 67 for the angle, and we get a ratio of 0.3907. And then for tangent, we find the tangent key, type in 12 for the angle measure, and we get a ratio of 0.2126. Okay, so as far as plugging the calculator goes, it's just a matter of knowing which direction you're supposed to go. So it's just gonna take some trial and error with you, and if you're having trouble with this, we can help you in class. Now, taking all that stuff that we just learned, what we're gonna try to do is put it all together now and teach you how to solve trig equations. So how do I solve for missing sides or solve for missing angles of a triangle? And so right now, we're just gonna focus on the sides. How do I find a missing side in my triangle using these trig ratios? So first thing, notice at the top here, we have just got kind of a generic equation. And so what's really important here is that when we're setting up our equation, we're gonna pick a trig ratio, so sine, cosine, or tangent. That's always gonna be the first thing we try to decide. Now that sine, cosine, or tangent is always attached to the angle. The angle always has to go right with the sine, cosine, or tangent. Those two things cannot be separated. So always put the angle with your sine, cosine, or tangent. On the other side of the equation then, what we've been working on is how to set up the fraction, one side over the other side. So if I had sine, I would choose opposite over hypotenuse. Or if I said tangent, I would say opposite over adjacent. So you have to pay attention to which trig ratio you selected and then use that to set up the ratio on the other side. Now, as far as solving then, so if we come down to this first example here, it says the sine of 42 degrees is equal to x over 12. And so what we're looking at is we're trying to find a missing side. So this would be like my opposite leg, where the hypotenuse is 12. So if we're looking at sine, that's opposite over hypotenuse. Now, as far as solving goes, there's only gonna be two operations we have to worry about right now. Either we're gonna multiply by my sine, cosine, or tangent, or we're going to divide by my sine, cosine, or tangent. And so when x is on top, so anytime x is on top or the missing piece is on top, we are going to multiply. So what I mean by that is I'm going to set up the equation for x. I'm going to multiply the 12 over to the other side. So x is going to be equal to 12 times sine of 42. So in your calculators, for most of you, you're going to type in exactly what you see here. You're going to say 12 times sine 42, and then when you hit enter, you should get a result of about 8.0. When we do these, we can go ahead and round to one decimal place. We're just going to kind of keep things simple. So 12 times sine of 42 is just x equals 8.0. And so that would be my answer. So when x is on top, we're just going to multiply like that, number times trig. Now if we look at our second example though, things are a little bit different. First, we're using cosine, which doesn't really matter which trig ratio we're using. We solve the same way no matter what. But what is different this time is x is on the bottom. So whenever x is on the bottom, rather than multiply, we're going to go ahead and divide. So So we're not going to take 5 times cosine 68. We're going to take 5 divided by cosine of 68. So when I want to find x, I'm going to take my 5 divided by cosine of 68. And so again, for most of you, you can type it in exactly like you say it. You're going to say 5 divided by cosine of 68. And then when you hit enter, you're going to get a result of 13.3. Now, I want to take a second here and go back to the previous problem. I said for most of you, you type in 12 times sine 42 and you'll get your answer. If you go 12 times sine 42 and you end up getting a really weird number, then if you were someone who had to do the backwards operation on the last slide, then you need to make sure you go backwards here as well. So you would type in 42 sine, then hit times 12. Same thing on the other one. If I'm going to do this 5 divided by cosine 68, most of you can just type it in. 5 divided by, hit cosine, hit 68, and hit enter, and you're going to get your answer. But for others of you, the ones that have to do it backwards, all you're going to do is take 5 divided by, and then hit 68 cosine, and hit enter. And again, if the calculator part is a little bit of an issue for you, we can work on that in class with you as we go through these. Okay, so now let's go to that third example. Tangent of 45 is equal to 17 over x. And so again, we look at where x is. In this case, it's on the bottom, so we're going to go ahead and divide. And so when I go to set up for x, I'm going to take 17, the number, divided by a tangent of 45. And so for most of you, type it in just like you see it. 17 divided by tangent of 45. And what's kind of interesting here is we end up getting x is equal to 17, which should make sense because if we think back to our previous lessons, when we had a 45, 45, 90 triangle, the legs, opposite and adjacent, were congruent. And so the opposite and adjacent here should be the same. But again, you wouldn't necessarily need to remember that because now we can plug in the calculator and get the same answer. And again, if you're someone who has to go backwards, you're going to take 17 divided by 45 tangent and then hit enter. So if you're going backwards, just make sure you do that every time when you're going through the process. So now, let's take that and actually put it into practice. So here's where we're actually using those ideas that we just talked about. So I've got this right triangle. They give me an angle, and then I have my hypotenuse. So again, I always want to try to find that hypotenuse in every right triangle. And then I would also go through and label the two legs. So if I'm looking at 42 over here, opposite would be directly across. Adjacent would be directly next to. So I've got all 3 parts of my triangle labeled. Now if I look closely at this picture, I have to figure out which trig ratio to use. Am I going to use sine, cosine, or tangent to solve this equation or set up this equation? And so if I look, I don't have anything for the opposite leg, which means I can't use anything with opposite. I have the adjacent, and I have the hypotenuse, which goes with cosine. So I'm going to start off my equation with cosine of 42. The angle always attaches to the trig. So cosine of 42 is equal to, and now I set up my ratio. We always go adjacent first on top, so x on top, and then 31, the hypotenuse on the bottom. And so this is the first step in this process, is just making sure we get the right trig ratio and making sure we get everything set up correctly. Once I get to here, I notice that x is on top, so I'm going to multiply. So in my calculator, I'm going to type in 31 times cosine of 42. And so that part you guys can kind of follow along with. So 31 times cosine 42. When you hit enter then, x should come out to be 23.0. Again, we can just go to 1 decimal place. Now, as far as checking to make sure this makes sense, if we know what the hypotenuse is, in this case the hypotenuse is 31, that has to be the biggest side in our triangle. So when I go to find a leg, I have better find a number that's less than 31. And so 23 is less than 31, which means I did the right operation. If you were to type in 31 divided by, so let's say you messed up and you tried to divide. So 31 divided by cosine of 42, you're going to get 41.7. Well, 41 doesn't make sense because that's bigger than the hypotenuse, which can't happen. So that's something else you want to kind of keep in mind as far as checking answers. Now, I do want to point out at this time, for these types of problems, you cannot ever just give me an answer. You cannot just say x is 23 with no support. You have to show me your original equation. So how did you set it up? What trig ratio? Did you put x on top or bottom? And all of that. You need to then show me what you plugged in your calculator. So did you do 31 times cosine 42? Did you do 31 divided by cosine 42? So what'd you do in the calculator? And then you can give me the answer. If you don't show the work to go along with your answer, you will not receive credit for the problem. So make sure you're showing me what the equation you set up, what you plugged in the calculator, and then your final answer. So let's go to another one here. So in this one, again, we kind of start thinking about, so based on the angle, so they give me this 47-degree angle. So my first thought is to find the hypotenuse, which is over here, across from the right angle. And then from my 47, across the triangle is my opposite leg, so there's x. And my adjacent leg is right next to it, 7. So if I'm thinking about which trig ratio to use, I notice that the hypotenuse doesn't have a value. Well, so if that's the case, I can't use anything with a hypotenuse, which means no sine, no cosine. So I do have the opposite leg and the adjacent leg, which means I can use tangent. So I'm going to set up my tangent of 47. The angle always goes with the trig. When I go to set up my fraction, the opposite goes on top, so x. The adjacent goes on bottom, so 7. And now if I notice here, x is on top, so I'm going to multiply. And so in my calculator, I'm going to take 7 times tangent of 47, sorry. And so if I plug that in, we get a value of 7.5. And so again, you need to show me the equation. So we chose tangent because we had the opposite and the adjacent. We then multiplied because x was on top, and then we got our answer by plugging into our calculator and getting the decimal. Okay. Now, when we look at this one, I want to kind of do something a little bit different here. So I'm going to put another piece of information into this problem. I'm going to say that this side is y. I want us to find both x and y in this case. So here's the deal. I look at where my angle is, and I'm going to have two equations that I have to solve. So as I'm looking at this problem here, what's going to happen is I have my 17-degree angle. I know that across from my right angle is my hypotenuse, so that's x. And I know then from my 17-degree angle, the opposite side would be y, the one across from it, which means my adjacent side is the 9.7. So as I'm looking at this, I need to look at x and y separately. So I'm going to look at x first. X is the hypotenuse, and I want to try to solve for that. Well, so the only other piece that I have to go with that would be my adjacent. So if I have adjacent and hypotenuse, that tells me I need to use cosine. So I'm going to start setting up my cosine. So cosine of 17, the angle always goes with the trig. When I go to set up my fraction, adjacent goes on top, so 9.7. Hypotenuse goes on bottom, x. And now I have an equation I can solve. Since x is on the bottom, I'm going to divide. And so for x, I'm going to take 9.7 divided by cosine of 17. And so now if I plug that in my calculator, x comes out to be about 10.1. So there's one of my two variables. So that's one equation. That's what I'm going to start with there. Now to find y, I need to come back and do something completely different. So if I'm looking at y, that's the opposite leg. And then they also started me off with the adjacent leg. So I've got opposite and adjacent when I'm working with y. Well, opposite and adjacent talk about tangent. So I can come back to my angle. Tangent of 17, the angle always goes with the trig. And so when I'm looking at this, For tangent, as I set up my fraction, I do the opposite, which in this case is y, divided by the adjacent, which in this case is 9.7. And so now when I look at the equation, I notice y is on top, so I'm going to multiply. And so when I take 9.7 times tangent of 17, and I plug that into my calculator, so 9.7 times tangent of 17, when I hit enter, I get an x value of about 3.0 when I round. So like 2.96, which rounds to 3.0, and so there are my two values. So if you're trying to solve for two different sides of your triangle, you need to make sure you set up two completely different equations. So figure out which two trig ratios you need, set one up to find x, set the other one up to find y, and then solve using your multiply or divide. So with that, you should be able to use those examples and use these notes here to try to work through the worksheet for today. And so that worksheet's on Google Classroom, where you can get it in class. And then if you have questions, make sure you ask in class or email, or you can use the answer key as it becomes available to you.